Hey, Algebra 1B. Today we're going to look at lesson 108, which is dealing with a topic called radical equations. Now, before we really get into this, I want you to think back. A couple of lessons ago, we had a topic where we had maybe an x squared equals some number, and we looked at difference of squares theorem, which said if we solve for the x squared, we're allowed to come in and square root both sides of the equation as long as we did positive and negative square root. Whenever we square root a square, the reason I bring this up is I want you to remember that squaring and square rooting are opposite or inverse operations. So when you square root a square, they cancel, leaves you just that x. And then we would simplify the square root of 4 to be 2. So we did some problems like that. Now today's stuff, we're going to work a little bit differently. We have what's called radical equations, which means we have equations, so there's an equal sign, but somewhere in there we have a radical or a square root. Okay? Now our process to solve this, most often the variable that we're going to solve for is going to be under that square root. So we need some way to solve this equation, but to get that x out from under the square root. And here's how it works. If you look at this first example, label that number 1. First thing we need to do in a radical equation is we want to isolate the radical. And the radical is that square root. So we want to get the square root by itself, which means in this problem, I need to get rid of that minus 2. To get rid of the minus 2, I'm going to add 2 to both sides. So that leaves the square root of x minus 4 equals, on the right side, 6 plus 2 is 8. Okay, so now we've got that square root by itself and it equals some number. We need some way to get rid of that square root. So we need to undo the square root. Now I brought up that example right at the very beginning that squaring and square rooting are opposite operations. So if we need to undo the square root, we need to square it. So in an equation, we are allowed to, we're allowed to add the same thing to both sides, subtract from both sides, multiply, divide. We're also allowed to square both sides of the equation. So I'm going to square the right side, or the left side, and I'm going to square the right side. Now, you're going to hear me say square the entire side, because sometimes these problems will get a little bit messier and we'll have more than just a single number on one side. So we square the entire side. When I square the square root, they cancel each other out. So I'm left with x minus 4 equals square 8, you get 64. Now this problem looks a whole lot easier, and we simply need to solve for x. So to do that, I add 4 to both sides, and we get x equals 68. Okay? Not too bad once the square root is gone. Now, on these problems, we have to go one step further, and that is we have to check our answer. So we're going to take that 68 and plug it back into the original problem, and we have to make sure that it works. So if I plug in a 68 for x, that's 68 minus 4 minus 2 equals 6. I have to make sure that works. 68 minus 4 gives me 64 minus square root of 64 minus 2 equals 6. Well, the square root of 64 is 8, minus 2 equals 6. So this one does work out down to a true statement. I have to make sure that I end up with a true statement. This one works, so our answer is good. Every now and then you will get an answer down there at the very end, once you plug it back in and check it, that you don't end up with a true statement. So then you have to throw out your answer. There's just no solution. Okay? Let's move on to the second example. Number 2. This time I have a square root. I have 2 different square roots in the problem. Again, we want to isolate those radicals. In this case, we have one square root on one side, another square root on another side. There's no extra terms outside of the square root. So this makes this problem a little bit easier. We've isolated the square roots. We got one on each side. Now we're going to go through the process like we did on the first one, is we need to square both sides of the equation. Again, remember, when you square a square root, they cancel each other out. So on the left side, I'm left with 4x minus 5 equals, on the right side, square root's gone, I have x plus 4. Now again, we're down to a much easier problem. We're going to solve for x. We subtract x from both sides. We get 3x minus 5 equals 4. Add 5 to both sides. 3x equals 9. Divide both sides by 3. X equals 3. That should be our answer. Now we need to check again. So I plug in 4 times 3 minus 5 equals 3 plus 4. Sorry, I'm running out of room here. So now we check. 4 times 3 gives me 12. 12 minus 5 under that side. On the right side, square root of 7. Well, square root of 12 minus 5 would be the square root of 7 equals the square root of 7. Okay, I really don't need to go any further because that is a true statement. I could take it out to a decimal. They're not really going to simplify anymore, but square root of 7 equals square root of 7. That's a true statement, so 3 is a good answer. I can leave it. All right, now this last problem. This one looks the messiest because somewhere in there we see an x squared. And then we have a big square root with a bunch of stuff under it. Follow the same process, okay? Let's switch colors. Go back to red. Again, first step, isolate the square root. So this plus 2 needs to go away. So I'm going to start by subtracting 2. So that leaves this big square root of x squared plus 3x minus 10 equals, on the right side, x minus 2. Those are not like terms, so I have to leave it as x minus 2. All right, next step, we have the square root by itself. So our next step is to square both sides. So the left side, I square. Now, the right side is where it gets messy. Since I don't have a single term, I have multiple terms there. I have an x minus 2. When I square this side, do not square x and square 2 and say we're done. When I square this side, when you have addition or subtraction and you have to square it, best thing to do is just write it down twice, which means I'm going to need to FOIL that side. Okay, let's do that first. When I FOIL this, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. So we combine our like terms. We have an x squared minus 4x plus 4. Okay, that's what we got when we squared the right side. Equals, when we square the left side, remember, square root squared cancels. So we now have x squared plus 3x minus 10. All right, I know it looks very messy, but it's really going to work out pretty good because if you look at this, we have x squareds on both sides. If I were to get them together by subtracting x squared, what happens? Well, you're going to see that those x squareds actually cancel off. So now we're down to a much easier problem. 3x minus 10 equals negative 4x plus 4. So we solve for x. I'm going to add 4x. So 7x minus 10 equals 4. Move this down just a bit. I'm going to add 10. So 7x equals 14. Divide both sides by 7, we end up with x equals 2. Okay, now again, we need to check our answer. I'm going to write it up here. We plug in a 2. Squared plus 3 times 2 minus 10 plus 2 equals 2. So we plug in our answer for x and we check to make sure this works. 2 squared is 4. 3 times 2 is 6. All that is still under the square root. Plus 2 equals 2. Well, 4 plus 6 is 10. Minus 10 is 0. Square root of 0 is 0, so we get 2 equals 2. The answer checks out. It's a good answer, so we don't have to get rid of it. Okay? So, big thing to remember in radical equations. Number 1, isolate the radical. Get that square root by itself on one side. Then we square both sides of the equation. Be careful on ones like this last example, where whenever you square the side, you have to do the FOIL method, so watch out for that. Square both sides, and then that square root is gone, and then simply solve for x. Okay, this is lesson 108. Good luck.